All right. Thank you for coming here today. Um, Sorry, we're not going to talk about any romantic stuff, date. It's mostly about how to deal with the date object in a Kotlin world and how to manage and handle them. I hope that this talk is from beginner to most advanced, I hope, engineers. There is a lot of knowledge and history. Last year I did a live coding session. Please don't expect 1,000 lines of code this year. It's mostly global and good practices. I'm Renaud Mathieu. I'm a member of the Paris Android user group. I'm also the guy that gave probably the most talks in this room. So with Edouard at the back. So I know this room in the history of Android makers at the Befra. First question today: what day is it today? First question we are going to ask ourselves. This question might be strange at first, but we are going to explore that it's not so easy to answer this question because we have many constraints, like different calendars. I like this one, the current year, according to various historical and world calendars as of January the 1st. So we are in the world that the most common one calendar is the Gregorian calendar. It's a solar calendar, meaning it's based on the length of the time the Earth is orbiting around the Sun. It was introduced a long time ago after a reform of the Julian calendar. It's the most widely used calendar in the world, and as you know, there is many particularities, like the number of days in months varies according to the month, the number of days in a year according to the year, and we have leap years, as you might know, every 4 years. Fun fact, and maybe you will see there's a lot of fun facts when you're dealing with date. The Gregorian calendar is accurate to within a day every 3,236 years, which means that over the time it will slowly drift out of sync with the solar year. The second problem we have, of course, time zone. This is the map of the world with the different time zones. You can see there's many of them, and as you can see also, it depends on the country you are. We have the time zone database, or the TZ database. It's a collaborative compilation of information about the world time zone. We also call the TZ data the Olson database because of the name of the first maintainer, the main contributor. And as you can see, it evolves all the time. So, for example, last month, Lebanon, for a day, they had 2 time zones because they changed for the daylight saving time, and then they say, oh, we're going to postpone, but we pushed everything in this repo, so it was a hotfix right after. And since it's evolving quite a lot, for example, here, it's from the what's new on the time zone data, so you can find this online. It's like the release note. For example, Egypt, they are using, again, daylight saving time from April through October. Morocco decided to change when spring starts in their country, etc., etc. We had also some kind of very fun things, like maybe quite some months ago. The fun part is at the bottom. They actually changed one of the time zone name. It used to be Pacific Enderbury, and they changed it to Pacific Canton. Why? Because they figure that since 1993, nobody was living in Pacific Canton, so it makes sense to put the name of where people are actually living, so they renamed it, because it makes more sense for people living in this area. Third problem, the rotation of the Earth is not regular. Why? Because of the tidal effects due to the moon, the sun, earthquake, other unpredictable and irregular internal phenomena. So what we have the universal time, which is the standard based on Earth rotation time. We also have the international atomic time. It's the average of time kept by 450 atomic clocks around the world in almost 80 laboratories. So this is very precise. And After that, we have the UTC, or the Coordinated Universal Time. It's a time scale between the TAI and the UT, stable but disconnected from the Earth rotation. It directly relates to the Earth rotation, which is slowly varying, so that's why we introduce sometimes some leap seconds, which means that we kept it in sync. And fun fact, at the moment, we have 37 seconds shift from universal time when dealing with UTC. Fun fact I discovered, UTC means Coordinated Universal Time, but they are dealing with French on its temps universel coordonné, and for them it was Coordinated Universal Time. Handshake, yeah, we figured the name, it's going to be Universal Time Coordinated or Universal Temps Coordonné. That's why we call that UTC. You might ask yourself, okay, but what's the difference between UTC and GMT? So the GMT is the solar time, based on the solar time at the Greenwich Mean Time. And the UTC, as I said, it's something between the atomic time and the solar time. So these are the most problems we have when dealing with time at the moment. Fortunately, we have tools. And for the tools, I tried to split the tools that we have between two sections, the machine time management and the human time management. First one, for the machine time management, the Unix epoch. It measured by the time of seconds that have elapsed since January the 1st, 1970. And it's the beginning of the Unix epoch. Some adjustments were made due to the leap seconds introduced by the UTC, which is I wrote here. Fun fact, there is this year 2038 problem because they used the signed 32-byte integer. So in 2038, it's going to go back to 0. So that's why they changed it to a signed 64-byte a long time ago. So we should be okay, except for if you are using your grandma computer. Sometimes we mistaken the name of Unix time and we refer it to the epoch time. But actually, you can define whatever epoch you want. You can consider that one epoch from your computer is going to be January 1st, 2000, for example. So usually, we're referring to the epoch time as the Unix time. Or we call that the epoch. Second tool we have is this standard, ISO 8601. The goal of this standard is to try to think about a solution to manage machine time management and human time management. You probably are familiar with this notation. It's an international standard. It's covering the worldwide exchange and communication of date and time related data. How to read this? Date and time values, they are ordered from the largest to the smallest unit of time. So we have years, month, week, if we specify the week, day, hours, minutes, seconds, fraction of seconds. So English people, when they put the day before, it's not going to work in this standard. I'm making it short here, but there is some documentation how to correctly implement this notation. And with this, actually, it's in between from the human time management and also the computer or machine time management. So that was the introduction about the problem we are facing and some tools and solutions that we have from them. But let's talk about the history of time in a Java world, and this is what I try to sum up here. And we're going to explore the first one very briefly. I assure you it's going to be java.util. If you have a project with this import, try to get rid of it. It has been very complex. It has a lot of unserious design flaws. From the day it was introduced, it has been deprecated. That's why they introduced java.util calendar in the version of Java 1.1. It's poorly understood by developers. It has been badly abused by library authors. It's adding confusion. For example, a date instance represents an instant in time and not a date. It doesn't have time zone. We don't have format. It doesn't have calendar system. The other problem is here. if you put this, it's mutable for the years, it's mutable for the months, it's immutable for the days. If I try to mutate the years, 2023, then the output will be 3,923 because it starts to 1,900 year, so it's adding years to the 900. So yeah, at the beginning it's weird. So try to not use it, but we will talk about it later. Then we have, I'm summing it because it's a 20-minute talk, so I'm trying to sum up the Joda-Time and the 310 ABP. Joda-Time and 310. Joda-Time was started in 2002, released in 2005, was born out of the frustration with the existing java.util.Date and calendar APIs, which were very criticized. Joda-Time aimed to provide a simpler and more intuitive API for handling date and time. Its design was used to define the GSR 310 that we're going to talk about. What is the 310? It was an implementation of a standard, the GSR 310. So that's why, fun fact, when I was reading it and I said out loud 310, oh yeah, 310. 310 backport and 310 Android backport are the name of the libraries inherit from 310. If you look at the 310 Android backport, so this is the README from the Jack Watson library that probably some of you have already used. Here, what we can see, we have some problem with the time zone management here. And the solution they figure in Android, Java, and 310 ABP was to take the TZ data that we see in the YANA database and put it into the jar. So what does it mean? It means that we have up-to-date time zone if you update your 310 version. And if you look at the release note, you will see that Jack Wharton or Dan Liu, they are maintaining Joda Android and 310 ABP, and they have scripts that keep the time zone up to date. So this is the solution they found for us Android developer to maintain the time zone. Another thing is it's an adaptation of the GSR 310 backport for Android. Development of this library is winding down. Please consider switching to Android Gradle 4.0, java.time, and add the core library desugaring. If you look at the link core library desugaring, if it was because we can use Java 1.8, and we have all the API to desugar, so we are good to use java.time, which is the next one, the GSR 310 and java.time. This API can be done accordingly to two main models. The machine time, basically it's a long integer whose value is an amount of time. It's a defined unit. It's an ellipse since a point of time, the epoch. The representation is exportable by a machine. And we have the human time represented by different value in different fields that allows you to specify different units and to do some operation on top of them. Let's have a look on the machine time management. We have the instant class. You might have seen this one. For me, I consider this as a machine time management. It encapsulates a point in time in nanosecond precision. It represents a point in the timeline. And if we do the match with java.util.Date, it's in java.time can be translated as an instant. An example, if you do, for example, the instant.epoch, then we see that's the Unix epoch. If we do instant.now, then you have the ISO format if you don't do anything from the standard that we have seen before. The duration class, it's a time between two instants stored with nanosecond precision. Duration can be negative. Something that I didn't mention in the standard is we have the ISO standard for period or duration here. It starts with a P, the number of days followed by D is optional. The letter T, time, indicates that the sequence corresponds to an hour. Then we have the number of hours followed by H, the number of minutes followed by M, the number of seconds followed by S. If I do a schema of it, it's this. So we have two instances, and then we get the duration. If we do some code here, so we have a duration of hours, we have a duration of minutes, and what is interesting here is when I'm doing duration between two instances, and I get the duration PT24. Again, it's a 20-minute talk. We can go more deeper, but these are the main class that we have to keep in mind. And we can go to the human time management. We have this object, the local date, final attributes. Before on the Java.util it was mutable, so they put everything as final. So the immutability encapsulate a date as a year, a month, a day in the ISO calendar. We don't have time zone here, it's local. It's very useful to encapsulate a date without a time, and for example, a birthday date. It doesn't have time zone, as I said, but it does not represent a point in time. We have the local time, encapsulated time, hour, minute, second, nanosecond, without a time zone. This class is immutable, and also something I forgot to mention, which was not the case in Java.util, this class is thread safe. Yeah. We have the local date time, and as you can see here, it encapsulates a date, so year, month, day, a time, hour, minute, second, nanosecond, still without a time zone. And what's funny here is that you have a local date, and you can do at time to add the time, and you get a local date time, and you can have a time, you do at date, and you add a local date, and then you get a local date time. And you can do some operation like day of week, so we know that when I did that, it was on Monday. We have period here. It encapsulates a period in time. It's the amount of time expressed in the form of various fields, allowing us to represent a period in a human way, such as year, months, days. Here you can convert the now, and the first line is interesting because what I'm doing is, okay, I'm taking the local date, and I can do some operation like minus week 2, and then it's kind of easy to use here. Same than before, but for duration. So it's basically the same thing, but with local time. And you can do some operation like minus minute here. Fun fact here, as you can see, I remove minus minute 40, but as you can see, I have local now and local now twice, which is not the same now in nanoseconds. So that's why it's not PT 40M. Now let's go to the time zone. There are two types of time zone. The zone offset, which is the time offset from the Greenwich Mean Time, is the same for all locations within the zone. And we have the zone region. For example, in Australia, there is different region, and for example, you can have 30 hours delay between one region to another, which is not common in France. And you also have some rules, and this is the next slide, where you can have some daylight saving time. So zone rules are the class that contains for each zone ID the rule to apply. And this is what is changing frequently, and these are defined by country. So we have the organization like the TZ data that are keeping these rules up to date all the time. One example here, a month ago, we had the daylight saving time on March. And this is what I did. I just created a local date time on March 26, a local date time on March 27, and I can ask for the time zone. I see it's not the same because I kept my zone rule up to date. One question you might ask is, okay, I have this zone date time and also I have this offset date time. What's the difference between the two of them? The zone date time is based on the time zone identifier and is used when you need to represent date and time information, and the offset is just the time between the UTC, or the period between 0 to 1 from UTC. Last but not least, the Kotlin date time. First thing I have to say, it's in alpha stage. the development continues. It's a multi-platform library, meaning that it can be used in both Kotlin JVM and Kotlin native project. This makes it easier to write cross-platform code that can be shared between different environments, such as server-side and client-side. The date time provides also serializable annotation to object like local time, and this is very handy when you're dealing with API. The date time has a more simpler or more intuitive API than java.time. For example, here I have the date time period, so I don't have to deal with period or duration, just have this object. As far as I know, the TZ data is provided, so the time zone rules are provided by the underlying platform. So if you are using the JVM, then it's going to be updated according to your zone rules within your JVM. And one other example that we have is we have some extension, so you can put right through your string in the ISO format, and you convert them to instant, to local date time, to local date, to local time, etc. What about today? So the question you might ask is, okay, there is java.time, but I'm sure that I am sure that the time zones are up to date. This is what I found: the project mainline. The project mainline is on top of the project treble. It simplifies how Google delivers update to the Android ecosystem, and Android 10, so it's quite new, modularize some Android system components, and they enable them to be updated outside of any Android release cycle. So basically, the end user devices can receive updates to this modularized component from the Google Play Store infrastructure. It depends on the partnership, so the OEM, and it's going to be over the air. The time zone rules are and can be updated through a dedicated module here for our Android devices, used by an Apex file, and the Apex file here stands for Android Pony Express. It's a container format that was introduced in Android 10, and it's used to install Flow for lower level system modules. With this initiative, I think that we should have to bundle time zone rules in our APK and can use them with confidence with java.time. At the moment, it requires what I mean SDK, the Play services, and I don't know if all the OEM are supporting these modules. So in my personal opinion, for now, it seems that I don't know if we're good. And this is my conclusion here. If I'm starting a project today, what is the library I should use? So don't use java.util. In my personal opinion, it depends. Are you building an app from scratch? Do you have an existing code base? Back in the day, the answer was use a date-time library that bundle TZ data, like java.time Android or 310 ABP. I'm not sure as today this is the state of the art. If your phone is wrong, then you're doomed. Ask yourself, what are the requirements for my app? I am building a calendar app and I have to have a strong usage of time zone or not. What will be my minimum SDK? Should I prefer something lightweight and future-proof and maybe go to multi-platform? It's up to you. Thank you for